First of all, could you summarize the work for which you're best known and for which you received the Turing Award?
It's pretty clear that what I got the Turing Award for was the work that we did on the Alto at Xerox PARC in the 1970s, where basically we invented all of modern personal computing except for spreadsheets. It was way too soon for the web, so we didn't have anything to do with that, but we invented graphical user interfaces and local area networking and client-server computing and laser printing, all those things that are familiar to you. We didn't invent spreadsheets, I think because we felt we didn't have any use for them. It turns out that nowadays, most uses of spreadsheets don't involve numbers. Somebody in Microsoft did a survey and found, I'm not sure I actually believe this, but they found that according to their survey, only 10% of the users of Excel know about the formula bar. The other 90% basically use it for making lists. And it has all kinds of wonderful facilities for doing database-like things on the spreadsheet. But anyway, you couldn't do those things on the hardware of the 1970s. And we didn't do spreadsheets because we didn't care about numbers.
What sort of applications did you foresee?
Well, we did word processing. In fact, I'm not sure whether this is still true, but it was certainly true 5 or 10 years ago that the basic data structures that were used in Microsoft Word were the ones that we invented at Xerox PARC in 1973. And drawing programs and programs like Photoshop and distributed file systems and just pretty much the whole range of things that you see if you sit down in front of a personal computer.
Now, as I understand, you also had something to do with multi-user systems way back in the 60s.
That was earlier. We didn't do that work, any of that kind of work at PARC. One of my major interests has always been in interactive computing. And in the 60s, interactive computing meant time-sharing systems because the individual machines were so expensive that it was unthinkable that you would devote a whole machine to one person. The Alto really was the first point at which the evolution of hardware made it even conceivable to do that.
Now, going back to the earlier times, because as I say, part of the HLF is about mentorship, and you were at Berkeley when you were doing the multi-user systems. Can you describe sort of what student life was like then as compared to now?
Well, there were many aspects to it. I arrived at Berkeley as a graduate student in physics in September of 1964. And I looked around for roommates, and I found 3 people who needed a 4th, and I joined that group. And 2 months later, 2 of my new roommates had been arrested in the first free speech movement demonstration. So student life was, I don't know what that makes it the same as it is today or different, but it certainly wasn't what I had been expecting.
But as far as the academics, was there anybody who really stood out at any point in your academic career as a mentor?
Things were a little bit odd at Berkeley. Of course, in those days, computer science didn't really exist. The Berkeley W department changed its name to Electrical Engineering and Computer Science, actually shortly before I got there in the fall of 1964. Because its then chairman, Lotfi was extremely far-sighted. But it's easy to change the name of the department. It's not so easy to actually start doing computing. And at that time, there were a couple of people on the faculty that had built machines in the 50s. But they were basically retired. They were not doing active work anymore. The titular leader of the time-sharing project that I joined was Dave Evans, who had done some pretty substantial computer design work in industry previously. But he was in the process of packing up to move to Utah, where he and Ivan Sutherland started the Evans and Sutherland Computer Corporation and did the first realistic airline pilot simulation systems. So his interests were really diverted. He wasn't paying that much attention to this project. The actual leader of the project was a graduate student named Mel Purtle, and I learned a lot from him. I did not learn all that much from the very small number of faculty members in computing that existed at Berkeley in the mid-60s.
Now, at that time, were you already thinking in terms of human-computer interaction?
Absolutely. The whole point of this time-sharing project was to have interactive computing, and to do it on a substantially lower, in a way that was much cheaper than the way it had been done, for example, at MIT with the compatible time-sharing system 3 or 4 years earlier. That was the first successful interactive computing project, but that was done on a modified IBM 7090, and we were working with hardware that was maybe a tenth the cost, and the goal was to show that you could get similar results on a much smaller scale. And that, in fact, led to the first general-purpose time-sharing systems that were actually sold.
Wow. So the period between, let's say, 64, when you entered Berkeley, and Alto would have been 73-ish, 72-ish?
We started it in the fall of 1972.
Okay. So that would have put you at about the same age and point in your career as a lot of the people here at the HLF. Mm-hmm. What were your thoughts about, like, how were you trying to find your way in the world? What did you think would happen, I suppose?
Well, people often ask me, when I was at Berkeley, I was sort of following my nose on this project, which had been conceived by other people. By the time I got to Xerox PARC, people often ask me, how much did you foresee of what would happen? And I think it's pretty fair to say that we foresaw just about everything. We really felt that what we were doing was the obvious thing to do. And we tried to. It's always been the case in computing that what's enabling is the hardware. As the hardware gets better, different kinds of applications become feasible that just weren't feasible with the earlier generations of hardware because they were too slow or too expensive or too big or too power hungry or whatever. So, random example, you couldn't really have laptops much earlier than the late 80s because the processors and the memory and the storage were just too heavy and consumed too much power. We did actually, at Xerox PARC, in a different group, build one of the very first, maybe even the first thing that was at all recognizable as a laptop in the very late 70s. But it was a complete bust because it weighed 20 pounds and it was so clunky and so slow that nobody actually wanted to use it. Another example, why do we have deep learning now? Until around 2010, we just didn't have the hardware resources to train interesting deep learning systems. So I had to wait for that capability to come along. Similarly, we built the Alto, essentially the first moment when memory got cheap enough that you could afford to use it to hold the display image. Previously, it would have been too costly. The Altos cost about $15,000 or $18,000 to build in 1972 dollars, which means $80,000 or $90,000 in today's money. So they were not commercially feasible by any stretch of the imagination. We viewed them as time machines. Our notion was that we knew, because we understood Moore's law, that 10 years later they would be similar devices would be commercially feasible. And we figured it would take 10 years to figure out how to write the software to actually exploit them, which indeed it did. And the first machine that was commercially feasible, that was based on the ideas of the Alto, was the Apple Macintosh, which came along in 1964, and it cost about $500 to build. Sold for $2,500.
You're putting the Apple Macintosh, well, I see, as the graphical, because I'm thinking of some of the
IBM
earlier...
PC was a different animal entirely in those days.
I was thinking the Apple IIG.
Well, that again was a different animal. It was a much more primitive system. It didn't have any meaningful graphical user interface. It didn't have any networking. It didn't have any laser printing. It was a good thing, and people got a lot of value out of it, but it was nothing like today's PCs, whereas the Alto was like today's PCs.
Although I'm personally very interested in personal computing history, I do feel that I should redirect it sort of to again how you found your path and the people here for the researchers who are at the HLF who are just now finding their paths. And I'm sorry, is this your first HLF?
No, this is the third time I've been here.
Oh, really? Have you noticed much change over the years in the
No,
HLF?
they seem to have found a fairly good formula. I think they're doing a better job each time at setting the thing up to facilitate contact between the laureates and the young researchers. Because, of course, the laureate's instinct is to talk to other laureates. And the young researchers, for the most part, are shy and don't like to bust in. So you need various mechanisms to make it more likely that there'll actually be interaction.
Well, tell me about the interaction that you have with the laureate, with the researchers here, the young researchers. How do they approach you, and what sort of questions?
Well, typically they don't approach me. Perhaps I sit down at lunch, and then young researchers will come in and sit next to me, and then we'll start to chat. Typically, they tell me something about what they're doing, and often it has some intersection with things that I've been interested in, and that will get the discussion going.
Have any of them brought up something that surprised you, or just made you realize, wow, there's a whole new field out there?
No, I don't think so. I think I keep up pretty well with what the whole new fields are anyway, because my interests are fairly eclectic.
How do you think the students are different today from when you were in school, aside from the obvious that there were no computers?
Well, the most obvious difference for computing is that when I was in school, everything was brand new, and there was a huge amount of low-hanging fruit. Almost anything you did was likely to be a significant success because no one had ever done any of those things before. And nowadays, the field is much more developed, and certainly in large parts of it, it's much more like traditional fields of study. On the other hand, there are also domains where it's still the Wild West.
What would you say some of those domains are that you find interesting?
Well, my grand theory of computing is that we started out using computers for simulation around 1950. And whether you simulated nuclear weapons or whether you simulated payrolls, the basic idea was the same. You build some model of the world inside the computer. You run the model, and it tells you something about what's happening in the world outside. And that was enormously successful. And it paid all the bills for the first 30 years. And it's still going strong. But around about 1980, 30 years after computing got started, hardware got cheap enough that you could start to afford to use computers for facilitating communication between people. And that brought us the internet and email and the World Wide Web and Facebook and all those other things that we know and love today. And that's been even more successful than computers as simulation, for simulation. And that's still going strong, and there's still lots to do. For example, the state of computer-mediated meetings between people who are not in the same room is still unbelievably bad compared to at least what one can imagine it ought to be. But it's been another 30 years, and it's time for something new, and I think it's crystal clear what the next great wave is going to be, and it's going to be non-trivial interactions with the physical world. And whether that means sensors or speech recognition or vision or autonomous vehicles, there's an enormous range of things which are going to have even much more economic and everyday impact than the communication, which in turn had much more economic and everyday impact than the simulation. So it's crystal clear to me that that's where the field is. Not that the other things are going to go away, because there's still lots of value and lots of interesting things to do in the other spaces. But this is going to be the most exciting aspect of computing, I think, in the next 2 or 3 decades.
And for people who, let's say, are tangential to, well, let me rephrase it in a different way. What you said is very inspiring, especially showing the history of how this could be a new wave following the 2 previous waves. Do you think that people recognize that today, that the young researchers recognize that there's a...
I think it's hard for them to see it because there's an awful lot of noise. And, if you just pay attention to the noise, what are you going to think? You're going to think that machine learning, which has been renamed AI, and blockchain are the most important things. And I don't really believe in blockchain at all. And although I think machine learning is a good thing, it's a long way from AI. So those are okay things. I'm not arguing against them, but I don't think that it makes sense to think of them as being the foundation of the next great wave. But if you just read what you find either in the popular press or even in the sort of popular technical press, things like the communications of the ACM, that's what you would think. So I think it's actually hard for young people to see clearly what I see clearly. Of course, maybe what I see is completely wrong. That is what I see. Well, and I do think it's hard for young people to see it.
Well, if I may, it sounds like you're primarily focusing on the application layer, so to speak. That is what the technology means rather than how it's done.
Well, I've done a lot of work in the area of how it's done as well. Of course. But now that I'm old and I'm too old to prove theorems or write code because I don't have enough concentration anymore to keep working on the same thing intensively for days or weeks, I spend my time thinking about the intersection between technology and various aspects of public policy or social life. So, for example, I've been spending time trying to figure out how to keep Internet of Things devices from killing people, which is partly a technical problem, but it's by no means entirely a technical problem. To put it another way, the interesting question is, what sorts of regulations of safety-critical devices would be best? You don't want regulations that allow the marketing of devices that are going to kill lots of people. On the other hand, if you make the regulations too tight, then you won't have innovation, and you'll sacrifice a huge amount of value.
Do you think that young researchers, such as the ones here, recognize the importance of that layer of meaning behind what they do?
It's hard for me to judge. Some of them certainly talk the talk. It's not. My guess is that if you're a fast-track young researcher, you're really focused on the technical things that you're doing, and you don't really have enough experience or interest to think seriously about what the broader implications are. I think that's just naturally the way the world works, and there's not a lot you can do about it. Other people are going to have to take up that slack. And there's certainly no shortage of people who are trying to take it up, in many cases perhaps not very productively. Now, I mean, just to pick a random example, there's a huge flap over the last few years about net neutrality. And my personal opinion about net neutrality is that's a problem that might come to pass. I can think of a lot of scenarios in which it's not going to be an issue at all, and it's certainly not an issue, an actual problem today. And I think it's way premature to wring your hands about it. It would be much better to just let things slide for a few years and see if it turns out to be a problem or not. And if it does, then you could make some rules.
You'll have to excuse me. I don't remember how much time you spent in academia. I know you spent quite a bit in.
I've been an adjunct professor at MIT for 30 years.
There we go.
But I was on the faculty at Berkeley in the late 60s for 2 or 3 years. But other than that, I have not been an academic.
But you do have some experience of people coming to you as, looking for ideas and leadership and such. What's your style for when someone comes to you and says, I need help, I want direction?
Well, it depends very, very much on what sort of things they want to do and how close they are to something that I'm interested in. There have been a number of cases, and by no means all cases, where it's a student coming to me, it might be a colleague in an industrial lab as well, where there's pretty close correspondence between what they're interested in and something that I've been interested in. And then typically we end up collaborating. There have been many other cases where people just want some advice, and I tell them how I think the world works and what I think is going to happen, and then they have to run with it.
What about here at the HLF, where interactions are, of course, by nature somewhat brief?
Mm-hmm. Well, I tell people what I think is important about something. I was chatting with a couple of the researchers about my views about blockchain, for example. I don't know whether I made any converts, but my story for blockchain is the value of blockchain is shock value. In fact, I'm contemplating organizing a talk, the title of which is going to be Block Shock. And what I mean by that is that the important thing about blockchain is not the distributed ledger or the cryptocurrencies or the smart contracts or any of those things. It's that there are many, many processes that are important for the day-to-day operation of the real world that could benefit a lot from being rethought in the context of computing. But there's a huge amount of inertia in the real world. So, real estate records for the state of Illinois, it's a very primitive uses of technology there. It seems pretty clear that you could make things a lot better with intelligent computerization. But there's also a lot of inertia in the system. But now with blockchain, people come to you if you have one of these processes and they say, what are you doing about blockchain? And if you don't have an answer, you look like an idiot. So you have to start thinking, even though in the end, probably what you do is not going to have anything to do with blockchain. This is not a popular doctrine, I should say.
I just want to bring...
Here's an example of the kind of discussions that I have had with some young people at this meeting.
And what are the reactions to that?
They're polite. Often, if they're into it at all, often they have a big emotional commitment to aspects of the blockchain phenomenon that I think are fairly bogus. So, it depends.
What do you hope that the researchers here take away from you, and in your communications with them, what do you find they actually take away?
It's very hard for me to know what they actually take away. Often it takes a long time for these things to play out, and typically I don't have that much contact with them afterwards. What I hope they take away is some sense of the scope of the enterprise that they're engaged in, and how to think about how to decide when something is important and when it's not so important.
Relatedly, what do you think the criteria are for that?
It's very hard to know. A story I like to tell is, for the first 30 years of the life of the internet, overwhelmingly the most important application was email. If you read the justification documents that were written to justify spending the government's money on the ARPANET, which was the prototype for the internet, email isn't mentioned. Why do you suppose that is? It's because it hadn't been thought of. So it's very hard to predict how things are going to play out. Sometimes I think it's easy to predict. I thought at the time, and I have continued to think, that it was easy to predict what was going to happen to the things that we did at Xerox PARC in the 70s. I thought that was really obvious. But sometimes it's not obvious at all. And things play out very differently than you imagined. The ARPANET was justified in terms of sharing of expensive computing resources across the community of 20 or 30 ARPA contractors all over the US. That turned out to be pretty unimportant. But there are other ways it can play out. For example, the conceptual prototype for the World Wide Web was Ted Nelson's hypertext, which was invented in the late 60s and went absolutely nowhere for 30 years. And Ted was heard to say in the mid-90s, when it was clear that the web was a success, he said, "I mistook a clear vision for a short distance." So was that all clear from the beginning? Not really. I don't think anyone could really imagine what the web was going to turn into.
Is there anything else that you'd like to say either about the forum or the state of your interests at the moment? Those are two very different questions. Let me put it a different way. Is there anything else you'd like to say about the future of your particular interests?
Well, I think this broad question of how the technical aspects of computing are going to play in the larger world. As I said before, that's various aspects of that are the ones that have interested me in the last 5 years or so. So I mentioned the blockchain. What is blockchain really good for? And another thing that I spent quite a bit of time on is the question of what are sensible ways to regulate the use of personal data online. I don't think we've made a lot of progress on that question with things like the GDPR.
You take a negative view of the GDPR.
I think the GDPR is. No, that's too strong. But I think it's clearly not the end of the line. I think it's good that something like the GDPR, which is fairly unreasonable in a number of ways, has at least been done because it gives you something to push against, and it makes it clear that the telecommunications and computing behemoths are not completely in the driver's seat. But I think there's a long, long way to go. Basically, my view is that the regulatory system should support the proposition that your personal data is yours and you can control it. That's going to be modulated by a whole bunch of social conventions of one kind or another that are going to be different in different parts of the world. Random example that a young researcher was talking to me about recently. You might think that the price you pay for your house is personal information. Well, it's not. In the US anyway, it's a matter of public record. So these are complex issues that have to be worked out in a way that's very sensitive to local needs and demands and history.
And the other part of that question was about the HLF, about you'll be coming back, I assume, in future years?
It's a pleasant experience. I'm sure we'll be coming back, yes.
Anything else that we should have talked about?
Nothing that springs to mind.
Okay. Well, thank you so much for taking the time. I appreciate it.
You bet.